Hello and welcome to my 4-week project overview. My name is Andrew Peters, and for this 4-week project I decided to make an Arduino powered gimbal. So for this project I followed a tutorial which I'll have the link in the description. It was a really good tutorial. It gives you all the directions, gives you all the code, gives you all the STL files for the 3D printed parts you need. It's really, really good. It has everything you need. So, first part of the project was testing out and understanding the accelerometer. So what you see on the screen is a video, and in this video I am showing off the code and the first part of this project. So what this code does is it takes a reading from the accelerometer and it displays the position of the accelerometer in degrees. So if I press play here, you'll see there's the code. Um, and right now you'll see that I only have the accelerometer wired up. I don't have any of the servos because this part is just about understanding the accelerometer. So when I go into the serial monitor here, you'll see that the numbers are moving. And as I move the accelerometer here, as you'll see, as I move the accelerometer, numbers move. So that tells me that the accelerometer is working exactly how I want it to. The next part of this build was wiring up the buck converter to have this project powered by batteries, as well as wiring up the servos. So on the left here, that left picture is the buck converter. That's the in portion, so that's taking power in, and on the other side it puts it out. Now for this project I ended up not getting the right kind of battery, so the voltage ended up not being high enough. So when I did it, I powered the whole thing on my computer, so I didn't actually need the buck converter. However, if you do follow the project and use the same batteries that the guy in the tutorial uses, you should have more success. Anyway, the picture on the right is all my power and ground. I was kind of unorthodox. I used orange for power and black for ground. And here is the big part. So the first picture, I'll go from like we're reading top left to bottom right. So the top left picture, you'll see the left portion we have an orange and black cable for power and ground, which powers the Arduino. On the right portion we have a green and an orange cable which go to A4 and A5. Now the A's stand for analog, which analog is receiving information from a device. So in this case the Arduino is receiving information from the accelerometer. Now what that means is the information it's getting on the A4 and A5 pins is being used to output on the digital pins, which I'll show later. So those are outputting to the servos as well as to the accelerometer. And this top middle is another picture of it, just a little better view, less confusing. The top right picture is the wiring which goes to the accelerometer. The orange and black, which are the first two farthest away, are power and ground. Then the next two is the orange and green wires, which go, as you saw, into the A4 and A5 pins on the Arduino. And that blue pin goes into the D2 pin of the Arduino. And so that means that the Arduino is doing some conversions and making sure that the accelerometer knows that it knows that it's where it is. So this accelerometer tends to drift out of sync with itself, so it gets confused and it doesn't always track itself exactly because it's not as high quality. So by hooking up this blue pin, it helps keep it stabilized and in the correct place. This bottom left picture is another shot. It's better to see what the individual pins are hooked up to. So as you can see on the right, I guess this is the bottom left picture if I didn't say that. On the right is the power and ground, then you have the two analog pins that go to the Arduino, and then the blue one is that D2 pin. The bottom middle picture is how we wired up the servos. So the right black cable is ground, the middle cable is power, and that yellow cable is reading from the Arduino telling the servo exactly how far to turn and in which direction. And in the bottom right is another shot of the power and ground hookups. There was a lot, and I don't think I did this in the best way, but it's what worked for me. So now I'll show you a little bit of the code, if I can find it. Hold on. Alright, I'm going to... Alright, so, sorry, I had to open up my Arduino program. Anyway, here on the right side, we'll do this one first. This is the first program that was given by the tutorial. And so this first part is, I'll just briefly explain each part. This first part is the setup, which brings the libraries into the code and allows so libraries allow you to not use as much code. It's basically some given functions, and so this first part is just calling all the stuff that that it needs from the libraries to help the code run. And this is the code where it reads information from the accelerometer, converts it from radians to degrees, and then right here it will output to the serial monitor so you can see that it's actually working. It's pretty basic. I'm not an expert with Arduino, so some of this stuff goes a little over my head, but that's my basic understanding. And here is the actual Gimbal code, which tells the servos to run. So this first part again is all library stuff, just setting up the code to make sure that everything gets in the right place. This initial setup is reading from the accelerometer and seeing where everything is, and then it sets the servos to a given value, which is right here, and that basically just is this starting position that they will always return to when you start the program. And so this is the part I had to change a little bit to get it to correct. Everybody's is going to be different, so I won't go too much into it. You just kind of have to test out numbers until it works for you. And then here's the main program loop, where it is basically, this is a very basic understanding, but it is reading information from the accelerometer, telling the servos which way to go, and then it is also making sure it's not overcorrecting or undercorrecting, basically keeping this platform as stable and flat as possible. If you want a more detailed explanation, you can download this code from the tutorial as well as read through the tutorial, as it gives a very good explanation of all the code. And so finally, if I can get back to my presentation here, this is my first attempt, and I'm not going to show it on video because I had a little bit of hiccups. I think my wiring was a little goofed, and I had to fix those offsets that were in the code. Anyway, it didn't go as planned, but I eventually got everything fixed, and if I could play this video, this is my final result. As you can see, the platform stays very stable and keeps the tape right in the middle. No matter where I move the base or how fast I move it, it does a very good job of reading from the accelerometer and keeping that platform stable. Anyway, thanks for watching, and check out the other projects on Vision Tech's YouTube channel.